So first disclaimer, I'm working for a security monitoring service provider called Offensity. So I might be a little bit biased on one of the slides. Second disclaimer, I'm software developer and no security expert. I'm the one in our team that's actually coming from an computer programming background. The other ones in my team are penetration testers and security experts. So I'm not fairly new to the topic, but at least in my team I'm not the official expert about security. But as I'm working in this team for now more than 1 year, I thought it might be interesting to share some patterns that I saw when working with customers, what different levels of security you can achieve and how you can improve your security step by step when doing software development. First off, I thought I'd give you some interesting numbers. There is 76% of breaches are financially motivated, meaning usually people say, well, we're just a small startup, we don't have a lot of data that's interesting to hackers, might not be interesting for them to attack us at all, so security is not important. Financially motivated means they'll try to install crypto software in your front end, in your back end, boot up many cloud machines and computing power to just run coin mining stuff. Usually, or in comparison to grief or just fun, is just a lot less big motivation in hacking. Another interesting statistics is comparing how much time does it take for attackers to get into your system and how much time does it take the attack organization to find out about this hack. So there's this huge gap of attackers just needing nearly 90% of all hacks being done will take only minutes, meaning these are the 90% of hacks are really obvious things that could be patched very easily, but yeah, it's not done, so it's very easy for the hackers to get into a system with very obvious flaws in your systems. And on the other hand, due to missing log systems and reviewing your whole architecture and systems, usually the organization will need several months to find out about this hack. So we have this 68% of hacks being only discovered after a month. Another interesting thing to get a little bit of perspective of security, 93% of breaches are caused by phishing and pretexting. So phishing and pretexting is really a big thing where most attacks are successful. The next biggest part is lack of security patching, having old servers, having not patching your application framework, not patching your front-end libraries. And the next big pillar is change management, which matches also the trend of going more and more to the cloud. Change management meaning you deploy new stuff, change something in your cloud provider, and opening holes into your systems by doing that and not having a proper process where another developer will review your changes. On the other hand, where is the vast majority of money spent? I guess I took these numbers from the presentation down here that are linked. So if you're interested in seeing the whole slide deck and getting even more information, you can go there. But my suspicion is that those security spends are mostly by big companies, meaning they pay a lot for authentication and authorization systems. They also pay a lot of money for malware detection and malware detection in the network, and also endpoint security, meaning antivirus software. And what's interesting in just mapping those two areas is that you can say authentication and authorization will nicely match the phishing and pretexting problem, but on the other hand, those big issues are not really addressed by the other big spending pillars. Yeah, so I'll give you just a short overview of what types of attacks to expect. On the one hand, we have automated attacks, somebody creating a script and trying to get in as many machines or finding as many machines with a certain vulnerability, meaning usually these people are not targeting one specific company, they found one security hole in software, and now they're trying to find a target where they can apply their vulnerability on. On the other hand, there is this highly customized attacks where they really have your company as the target. Usually these attacks are against bigger corporations where they want to get, where there's higher stakes if you get into the systems. The highly customized one usually take also longer, and you have to focus on really one company. Which targets do attackers address? So on the one side, if you're a software development company, you will have your product that you are most concerned of usually. Your product is the custom software that you're developing on a day-to-day business. And on the other hand, there is this infrastructure component that usually every company in the world nowadays has, meaning your email services, your file shares, things you buy from other companies and vendors, but those things are also very critical to your daily business. So those are the two components that you have to care about, and both components have different things that you have to care for. So what's the first step in improving your security as a developer? I'd say as an individual, be interested in security topics in general. So try to follow news posts when new vulnerabilities pop up, especially with your framework or your technology. Read through the problems they have and the problems they address, and you do it the same way as you would do with highly critical bugs. Get interested in those things. Usually, if you're using some kind of framework, or that's the general recommendation, look at the frameworks in your technology space and learn about the security features they provide. For example, as I said, I'm a Django developer, so there is one specific subsite on their documentation detailing all the features they provide in terms of security. I listed also, for example, Express.js. They also have a best practice site for security. Read them, get a feeling for what they provide and what you might miss in your framework or in your code, which you should work on. Also, if you're using a framework, try to subscribe to those mailing lists that will announce vulnerabilities as soon as they pop up. Again, there's one for Django, but I'm sure there is also others for JavaScript related stuff. NPM has one subsite detailing all the advisories. They have an RSS feed, I guess, or I've seen that you can also filter for the packages that you usually use and just subscribe on those specific advisories. And there's also this nice tool, Snyk.io. They also have a very big database and up-to-date database of new vulnerabilities in the JavaScript environment. So this first level is getting your small team more focused on security. And one good thing to start with is having code reviews. Try to find, or if you don't have any senior engineers already in the team, try to get senior engineers, since they will improve the whole code reviewing a lot. And usually or if you are a senior engineer, try to put the finger on critical parts of the code of juniors and talk through the issues you can find. Try to develop best practices in your team, write them down, make them clear to everyone. That's the most important thing that you can do as a team. Then two more technical things, hands-on things. Patch your servers. As said, it's 6% of all vulnerabilities are based on unpatched servers. So that's a real threat to your systems. It's not, you should do that on a very regular basis. On the other hand, one pattern that we saw with our customers, the ones that have a very high level with security, they usually also have the sense for using platform providers. Just to name a few, like Google App Engine, Heroku, or there are thousands others. Focus on the things that you're best with, and the whole patching and keeping your systems up to date, leave them to your platform providers, and also study their security-related documentation. So usually, Google App Engine and AWS, they all have security-related features. Read through the documentation and find out what makes sense for you. Another important thing, if you're developing your own product, isolate your assets. If you have a WordPress blog, for example, since that's a typical case, and you have your product custom code, don't put them together on one server. Find some, in the best way, you'd find some special WordPress hosting company and just put the WordPress stuff there and have your product stuff on another server. Centralized logging is also something that's very important to find out about problems you might come across, or if you're under attack. You need to have a system to go to where you can find out if there is somebody attacking you. And so there's central logging. There's also some software as a service company doing great products on this. Also, multi-factor authentication is an important thing to improve your security. So these are the steps that you can do totally in-house without doing anything special. Have a security policy. Have some dedicated email address where possible attackers can contact you, and be sure that this email address is also forwarded to one that somebody will read it on time. For example, there is right now, I'm not sure, it has been in the media right now, the Viennese library has been hacked some days ago, and there was exactly the thing that the hacker published 700,000 data records just because he couldn't reach anyone, and nobody followed up on his issues and on his vulnerability about a broken web application. So there are several layers how you can improve that. One very simple thing is having this security TXT on your server. It's nothing special, so just put in a mail address, and you might also want to have a key so that if somebody finds a vulnerability and wants to contact you, there is one secured way he can do this. Sorry. The next step will be having some specific security page. The Django project, for example, has this. They also detail the whole process on how, what they expect if you find something, how the process will work for the whole community, if there is a new vulnerability. So that's another good thing. And the last, or another level would be having a security policy published on HackerOne. HackerOne is also a big platform, bug bounty platform where other hackers can browse through companies that are willing to give money if you find a vulnerability. Yeah, Dropbox is doing that, for example. Also, I put in one link where you can find nice templates for creating security pages and security texts, like the one you like the Django page. Yeah. So publish a security policy would be the next level. What to do next? Regularly run vulnerability scanners against your infrastructure. This usually will not improve your product security, as you've done custom code development, and vulnerability scanners are the right tool for checking your infrastructure. So finding very obvious problems that the 90% that we saw previously, usually you can find them also with nice and good vulnerability scanners. They are very easy to start with. Usually you just type into your domain and they'll start checking your infrastructure. Look for a solution that provides a lot of good documentation if there is an issue that they find in your infrastructure. That's also something that will help your team increase security awareness. If you find nice documentation at your vulnerability scanner, that will help a lot as a starting point. Yeah, just to name a few, of course, there is Offensity, and there are another two big companies, Nessus Cloud, they are from Israel and market leader, and Qualys is also another big one. So there's usually something. But yeah, do your research in the internet, you'll find probably something that fits your needs. Penetration test is usually the thing that companies that try to start with security, they first go to penetration tests, so they don't care about security policy or improving the whole mindset in your development team, but they want immediately penetration tests. So I put this penetration test slide on purpose way back. Yeah, penetration tests makes a lot of sense for your product. They can check your code specifically and give you a lot of insights where you have problems. But the issue with penetration tests is only one-time check, of course. It costs a lot of money. It's a huge upfront investment, and it's of course of just limited scope to test your product. But on the other hand, limited scope is a nice tip also. Penetration tests make a lot of sense if you on purpose limit the scope to some specific area where the penetration testers have time to really look into and dig into that issue. Another tip that I would say makes sense is if you do penetration testing already, if you do penetration testing already, switch partners from time to time, as usually the report of penetration tests depends on the team that does it, and if you change teams, you will get different tests, different ideas, different viewpoints. So that makes a lot of sense too. I already mentioned HackerOne with the Dropbox policy page. HackerOne is a bug bounty program. So usually it compares somehow to penetration tests, since some individual would check your software and you define which parts of software or which parts of your infrastructure you want to have checked. If you are on that level and want to try out the bug bounty program, there is the great tip of, as a first step, do publish your security policy privately and invite some VIP researchers to start slowly with the whole program and not be flooded by new requests, since usually those researchers will expect you to respond very quickly. And if you are starting just with public, you will get a lot of trivial issues firsthand, and you will just drown in contact emails. Here's a nice case study from WordPress. WordPress is also a page on HackerOne. They've done, or the guy from WordPress who is responsible for the security, Aaron Campbell, published a blog post, and he said within 6 months they spent $14,000 on 22 different hackers. On average, for every report, they paid $350. And the interesting part is also only 16% of the reports they got in were valid reports. So there is this huge workload you'll have to expect from this kind of platform. Yeah. As a last slide, I wanted to also mention some in-house scanners. I would only recommend them for or if you're a bigger corporation, or if you work in a bigger corporation and you have the money, that might make sense. Yeah, two very popular ones also in our penetration testing team. They use Nessus and Burp Suite. So just for completeness sake, if you're interested, those are very nice tools to start with if you want to try something locally. Cool. So that's the official end of my general talk. I also tried to collect some JavaScript specific ideas from the rest of my team, where we thought the biggest issues are within the JavaScript community in terms of security. In the JavaScript world, there is this tendency to have a lot of module imports for very small software packages. So in general, be conservative about the things that you import from third-party developers, as a general hint. And if you import software from third-party developers, be sure to pin the version on a specific version, review the code, and use something like Snyk. Snyk, the tool that I mentioned previously, they have this vulnerability database for free, but they also provide a tool where you can just check your third-party library requirements against known vulnerabilities, and you will be alerted if there pops up a new vulnerability, which might be very handy. Yeah, if you link to some external CDN, be sure to use the integrity attribute, meaning there is, if you, for example, use a jQuery version hosted on some other CDN, there is this attribute integrity where you can provide a hash, and if this hash does not match with the contents of the file that gets downloaded, the browser simply will not will not process the JavaScript file. Meaning, if the CDN loses, if somebody is able to push into new JavaScript files into the CDN using this attribute, you will be safe, so that nobody can create phishing pages or whatever on your infrastructure. Patch your JavaScript libraries. One nice tool is this Chrome Lighthouse application. It's a general tool that will also check your page's performance, but it will also highlight if you use libraries that are out of date. Yeah, so the last 3 things that we came up with were understand the same origin policy, meaning data will not be downloaded from another domain. If your data like HTML files or JSON files, the browser will not download from another domain. But if you have JavaScript files, you can download them from other domains too. That means you don't ever put any secrets in your JavaScript files, and to be more general, also JavaScript files usually should be just static files and no dynamic rendering in your JavaScript. Content security policy is also a nice new feature. Most newer browsers have baked in by now. So learn about that. You can just restrict more on what the site is allowed to do. And the last point is if you're working with some backend developer, as I'm more from the backend side, usually there is this huge, or if you have a front-end team and a back-end team, usually the front-end team develops a lot of nice new features and demands a lot of queries from the backend, and the easiest way will be just open up everything and let the front-end people create cool new functionality. But this also, of course, opens a lot of security issues. So be sure to talk to your backend team if you have one dedicated backend team about the functionality you don't need anymore, so they can just strip down the deprecated ones again. Okay, for completeness, there is those 2 articles and tips and other links about security, what you can work on, where you can get more ideas, what to improve, and the link to the video. Yeah, that's it. Thanks.